In section 6.3, we're going to discuss binomial radical expressions. So just to start here, like radicals are radical expressions that have the same index and radicand. So for example, if I had the square root of 2 plus 3 square root of 2, since these have the same radical of the square root of 2, I can combine these. So you have 1 square root of 2 plus 3 square root of 2 can combine to give me 4 square root of 2. Likewise, if I have the cubed root of 7 minus 5 cubed root of 7, I can combine these as well, and I'd have negative 4 cubed root of 7. So overall, I can say that that's combining radical expressions for a sum or a difference. So generally speaking, a times the nth root of x plus b times the nth root of x, I could simplify as a plus b times the nth root of x. Same thing goes for subtraction. Notice here how I'm taking the nth root of x, so those radicals both look the same. That's when I can combine these. Another important thing to note here is that what's inside the radical doesn't change at all. So a common mistake will be like if I saw the square root of 3 plus the square root of 2, it's important to realize that that does not equal the square root of 5. So I can't combine what's inside the radicals. I can just kind of combine the coefficients or what's outside of them. So first, let's look at an example. 3 times the square root of 5x minus 2 times the square root of 5x. These both have the same radical of the square root of 5x, so I can combine the outside. 3 minus 2 would give me 1 square root of 5x, which I can just simplify to saying my answer is the square root of 5x. This next example, I have 6x squared times the square root of 7 plus 4x times the square root of 5. I have different radicals here, so I can't simplify this any further, and I'm just done. In this next example, I have 12 times the cubed root of 7xy minus 8 times the fifth root of 7xy. Well, I see 7xy under both of these radicals. I'm taking these to different roots, so as we talked about last section, I can't simplify this either. Another way that I can simplify or combine radicals is using the FOIL method when I'm multiplying two binomial expressions. So what I'm talking about here is if we had an example like this. 4 plus 2 square root of 2 times 5 plus 4 square root of 2. I'm going to use the FOIL method, and you're going to see I'm kind of treat these radicals almost like an x or a variable. Outside terms will give me 20. 4 times 4 square root of 2, I multiply the outside to give me 16 square root of 2. This will give me 10 square root of 2. And then my last terms, I'll have 4 times 2 gives me 8. So I have 8 times the square root of 2 squared. Looking at this all together, the square root of 2 squared will simplify to give me 2. 8 times 2 gives me 16. Now looking at my expanded form of this problem, I can combine like terms. The 20 and the 16 are both whole numbers. I can combine those. And 16 square root of 2 and 10 square root of 2 will combine because they have the same radical. So my final answer here would be 36 plus 26 square root of 2. Another thing I can do here is multiply conjugates together. This will be more important in the next example that we do. So for example, let's say I'm doing 5 minus square root of 7 times 5 plus square root of 7. From what I know about conjugates so far, I should be thinking in the back of my head that after I FOIL this all out, my answer should be this nice whole number. I've seen this when I've worked with imaginary numbers, how the conjugate will get rid of that imaginary part. Same thing's going to work for radicals as well. When I multiply my first terms, I get 25 plus 5 square root of 7 minus 5 square root of 7 minus the square root of 7 squared. Now, as we've seen in pretty much all the conjugates that we've done so far, the middle terms will cancel out. And now I'm left with 25 minus the square root of 7 squared. This will simplify to give me 7. My final answer here is 18. So I did in fact get a whole number as my answer. Now this is going to be an important thing to note when I'm rationalizing the denominator. So let's say I had a problem like this. 3 square root of 2 over square root of 5 minus the square root of 2. If I want to rationalize the denominator or simplify this problem, I don't want any radicals in my denominator. So if I'm looking at that binomial expression, I know that if I multiply by the conjugate, that's going to get rid of the radical on the bottom. So the conjugate here would be square root of 5 plus square root of 2. I'm going to multiply on top and bottom here for this problem. To start with the top here, I can just distribute that 3 square root of 2. I'm going to be left with 3 square root of 2 times square root of 5 plus 3 square root of 2 squared. That'll turn into 3 square root of 10, and then 3 times 2, which gives me 6. And on the bottom, I get square root of 5 squared plus square root of 10 minus square root of 10 minus the square root of 2 squared. Now simplifying some stuff down here, the middle terms again are going to cancel out. And I have this left on the bottom. Also notice what I did here in this next step. I pulled that 3 out of the numerator to leave me with 3 times square root of 10 plus 2. Now looking at the bottom, square root of 5 turns into 5. Square root of 2 squared turns into 2. 5 minus 2 turns into 3. And now notice on the top and bottom, those 3's cancel out. My final answer, totally simplified, is going to be the square root of 10 plus 2.